by now I got used to your food, to your way of life, and I must say that it is also enjoyable. It is so enjoyable that 2 months ago I got married with a lady from Bangalore. So I think that more enjoyable than this is difficult to enjoy. Allow me just to spend 2 words about BS India. I came here in 2007 as a sales and marketing director of BS India. BS India is a 100% owned subsidiary of BS Group, which is a leading group Italian for the manufacturing of machinery for panel processing, glass and stone processing. In India, we house 2 plants, one in Nelamangala for the assembly of the machine and one in Pigna for the manufacturing machinery. In India, we have about 750 customers, so we have quite a good base of customer, and total square meters available with us as shop floor are about 12,000 square meters. The machine that we manufacture in India are not only for the Indian market, but are exported also to other markets, where we have our network of dealer and agent. I must say that I'm honored today to be here with you and to touch the topic of cabinetry manufacturing. I know mainly 2 methods to make a cabinetry. So a method that I would define the traditional method, and a method that I would define as the nesting method. The traditional method is the method that is very much spread in Europe, and it is actually the one which is utilized mainly here in India. So I will then spend 2 more minutes talking about the nesting methods. Going to the traditional methods, the machine typically involved, I'm now considering mainly the production of kitchens, is the hot press. As we all know here in India, the pre-laminated boards are not so popular in the kitchen manufacturing. Things that is quite unusual because worldwide the panel that are usually utilized in the kitchen manufacturing are pre-laminated boards. If you start from a board that is plywood and needs to be laminated, there is no choice but to start with a press which pastes the laminate on the boards. After pasting the laminate on the boards, the following operation is the cutting. The cutting that can be carried out with a manual machine or can be carried out with an automatic machine. The difference is the fact that, again, one is manual, the other is automatic. One cut 1 panel at a time, the other can cut a stack of boards. So, of course, the productivity that is possible to achieve is higher with a beam saw rather than a sliding panel saw. Once the panel has been cut, the following operation is the edge banding. The edge banding is quite a delicate operation because it gives you the quality of the panel, the finishing that you can see on the panel. And according to the type of edge that you're going to apply, can be melamine, can be PVC, can be veneer, can be high gloss PVC, can be solid wood, the edge bander needs to be equipped with a different unit to be able to finish the panel. Once the panel has been edge banded, we need to drill the panel. So the classical operation for drilling are a manual solution, can be 1 head, can be 3 heads, can be 2 heads, or an automatic machine for drilling. Automatic machine for drilling can be either, a machine where the panel gets into vertical, or can be either a machine where the panel is processed horizontally. This is the traditional method. Later on, I give you some indication about the investment necessary for a setup to make 2 rather than 3 rather than 5 kitchen in 8 hours. But I would like to spend 2 more minutes about, I was saying, the process of the nesting, which is not at all popular here in India. All right. What is the nesting? Nesting comes from the word's nest, which means to position a certain number of parts, one close to the other, trying to optimize the space that is utilized. Nesting is a strategy that is actually already used in many other fields for the cutting of the plastic, leather, metal, and the cut can be carried out with the tools rather than with a laser or a water jet. It is a process that is very much popular in US and Australia, but slowly it is becoming popular also in Europe because of the flexibility that these methods is able to provide. So what are how, let's say, the nesting works? As usual, we have just said nothing happens if you don't have a software which is capable of programming your boards. You need to insert the parameter of your boards. The software generates the cutting pattern and the drilling pattern for the different elements. The machine that is required is not a machine with pods and rails, but it is a machine with a flat table. This table can be phenolic, this table can be in aluminum, but important is that it is a table as big as the rough material that you need to put on the top. This table actually works as a complete big caps, if you want, because the vacuum gets through this table and hold the parts that you're putting on the top. So, sorry. Once the program is created, this is the spoil board that need to be positioned on the top of the machine. The spoil board gets cut for 0.1 millimeter. So the tools get into the spoil board for 0.1. Finish products, and then the cutting and the drilling pattern. What are the benefits of nesting? Nesting is the fastest way if you want to go from a production which is mass production to a production which is in batch one. So in case you get an order which is different from the previous one in quantities, sizes, or in any case where there are some different parameters, the nesting is the perfect solution. You just need to recall the different program. The rough board gets loaded in his entire shape on the spoil board, and then the cutting program is executed. In the nesting machine, there are no caps and there are not pods and rails that need to be positioned. Again, as I was mentioning, all the surface of the machine becomes as a big cap which holds the parts. From there, the possibility of cutting any type of shape that you are capable of positioning into this board. What is another advantage of nesting? We were saying before the saving of material. Because of its way of working, the nesting in itself allows the saving of the material because it optimizes the space on which the panels are positioned. It is very much a concept of working towards the just-in-time. Just-in-time means that you get your order, you enter your order, your software elaborates the program, the different cutting, drilling program for the different machine, and in one single flow, the panel is cut, edge-banded, and drilled. Of course, this brings to a dramatic reduction of space that you required for semi-finished products. Minor training of the workforce. With this technology, with the technology of the nesting, actually there is no need to have a separate machine, which is the sliding panel saw or the beam saw to cut the material. Because in one single machine, both the operations are executed. So one machine actually is saved instead of the CNC and the beam saw. You have a flat table machine which can be also equipped with automatic system for loading and unloading the board. The machine can also be equipped with a barcode system to identify the parts once it has been cut. This barcode system can be positioned even at the beginning of the machine, even before the panel gets cut. So the different labels are pasted on the panel, and then it gets nested. The material handling, of course, is less. There is not the need to go from a process where you have the loading of the boards on the beam saw, from the beam saw, in some rare case directed to the edge bender or to the CNC. There is just the loading of the boards on the flatbed machine, and then directly to the bender. While the machine is nesting the parts, the operator can do some other job. The operator can, for example, load the edge bender. Consider that a cutting cycle, depending from the number of parts, the boards, and the drilling pattern that is required, usually takes from 4 to 8 minutes. So during this time, the operator can be utilized doing some other activities. Since there is now the cut processed through a scoring and a blade, which is the classical way in which the panel in the sliding panel saw or the beam saw are cut, so scoring and blade, but there is one single tool which cuts the material, the quality of the cut is for sure higher. The classical field in which the nesting process is utilized is cabinets and furniture, MDF doors, sofa frame. Actually, for sofa frame, it is absolutely the best possible option. Plastic materials. Regarding non-ferrous metals, so aluminum and alucomb, in this case, there is a process which is called folding, where V-tools, fortified tools, cuts through the material, leaving a small layer of material that now afterwards can be folded, and from here the different shape that is possible to achieve with this technology. I wanted to give an idea of what is a setup of machine required to achieve a certain production, in this case of kitchens. So if we target to produce 2 kitchens per day, and when I say per day, I consider 8-hour shift. Of course, if you consider 2 shifts, everything needs to be doubled. We need a hot press in case you don't buy pre-lam board. If the board is pre-lam, you don't need, of course, to paste the laminate on the panel. The panel saw. So the panel saw is, one panel saw is enough to cut the parts required to make this number of kitchen. An edge bender. So an edge bender can easily process the parts required for the manufacturing of, for the assembly of 2 kitchens. And then a manual drilling machine. For 2 kitchens in 8 hours, a manual drilling machine, I'm thinking about 1 horizontal head and 2 vertical head, is good enough for this type of productivity. Just to give you an idea about the investment required for this type of setup, we can be around 65 lakhs. And the space that is required for this setup is from 3,000 to 4,000 square feet. If from two machines, what I was mentioning includes also the accessories, so dust collector, air compressor, stabilizer, tools, and electrical and pneumatic setup. So in the number that I was telling you, these accessories that are usually required to start the setup are included. If you want to achieve a number of kitchens, which is, let's say, 5 kitchens in 8 hours, then the hot press, same story as before, so I don't want to bother you with this. For the cutting of the boards, then or you double and a half the number of the sliding pan and saw, or you go for a solution where the machine does not cut one single board, but cuts a stack of boards. The edge bender, still one edge bender, is good enough to manufacture the panels required for this number of kitchen. And in terms of drilling, then the manual drilling is no more sufficient to drill this number of boards, but you need to go for a machine that is a CNC machine, whether vertical or horizontal, but still the machine needs to be automatic. In this case, always considering the accessories involved in this setup of machine, here we are talking about an investment which goes from 1.2 to 1.3 crore. Space required between 8,000 to 9,000 square feet. Just to give you an idea what is possible to achieve on the other side with a nesting method, so if we assume that we want to achieve a productivity of 3 kitchens per 8-hour shift, price as usual, one flat machine would be good enough to cut the boards required. The edge bender, of course, covers the edge bending need, and the manual drilling actually is not always necessary. There are some countries like Australia where the horizontal drilling is not even processed at all. There they have some type of hardware that allows the holding of the horizontal and vertical element without making any horizontal drill. In US it is slightly different because there they go with the screw, but still the result is the same. So this machine, if you have hardware which allows the joining of the vertical and the horizontal element, or if you go just with screw, actually is not necessary. In a solution like this, including the accessory, dust collector, compressor, stabilizer, and tools, the level of investment is around 80 lakhs. And the space required is from 4,000 to 5,000 square feet. Consider that you save some space because there is not the cutting which is required. Actually, here we have tried to give a very rough idea of a productivity of 2, 3 with the nesting, 5 kitchen. But as BS, we can tailor-made a setup of machine according to the specific need of the customer. As we were saying before, it is absolutely important to understand what is the type, the typology of panels that you need, that the customer needs, and the quantity that needs to be achieved. In this regard, I wanted to share with you a layout that we have just made with an offer for an Indian customer. So this layout of machine is conceived for roughly 35 kitchens in 8 hours, plus 35 bedroom set, considering so the wardrobe, bedside table, and the bed. So it is clear that the machine that we've seen before cannot meet this productivity. So in this case, we need an area where the storage of the rough board is happening. So this is the storage for the rough board. Then we have actually two different lines in this single plant. One which starts from an angular sizing plant. Before I told you that there are machines, there are sizing machines that where it is possible to cut a stack of boards. Well, there are also machines where, besides cutting a stack of boards, in the same machine, it's possible to process the longitudinal cut and also the cross cut. This machine has a productivity that, of course, is much higher than the productivity that is possible with a single line. Single line is called the single cutting line is the machine which has only the longitudinal cut. Here we are considering a machine that is capable of cutting 5,500, 6,000 board in 8 hours. So having this cutting capacity that is, of course, mainly for carcasses. So in this case, having this big number of elements we produced, we have to differentiate the best way to manufacture the carcasses, because for the carcass there will be a certain flow. And shutter, rather than any elements which is not exactly squared or which is shaped in a different line. So in this case, we start from this angular sizing plant, double size squaring edge bending machine. The double size squaring edge bending machine is a machine that is not just edge bending the panel, but which is also squaring the panel. So in this machine there will be squaring unit, can be milling unit, can be pre-milling, double hogging, depends on the productivity and also on the material that is utilized. There are units which makes on the first machine, which is this one, the two long sides parallel one to each other. Then the panel gets rotated, enter in the second machine line. There are on the chain dogs, which takes the panel and push the panel perfectly square into the machine. Then the panel gets turned again, because the loading and unloading usually always happen longitudinally. And from the edge bending, we go to the drilling line. All these machines, of course, cannot be loaded manually. It's impossible to imagine to load an angular plant in the cross line or a squaring edge bending machine or a drilling machine by hand, because no human being can follow up the speed of the machine. So in all these machines, there are systems to load and unload the panel. Of course, between one machine and the other, there is an area where there is the storage of semi-finished products. As I was saying, this is the flow for the carcasses. Different is the flow for the shutter, eventually also office table tops, because this gentleman was also requesting the possibility of making some office table. So in this case, we have an automatic panel storage cell, which can load a beam saw, or which can load a flatbed machine. Again, going back to the previous slide about the flat table, this is the machine that allows the shaping of any type of panel, allows to make on the panel any type of shape better. After this storage cell and the beam saw and the flatbed machine, we have the machine related to the finishing of these products. So we can have a drilling machine, we can have edge bending machine. Here we have all, these are edge bender. These are two CNC machines with pods and rail. This is a routing edge bending machine, because also on curved parts it is possible to make a shape like an office tops, and put the edge on this top automatically. In this plant, it was also included a finishing line, which is not manufactured by us. so would be supplied by somebody else. So again, extremely important when you have in mind level of kitchen that you want to achieve. First of all, for us to understand exactly how many elements are in this kitchen, because the number that I have given you are for a kitchen which is 9 by 6, 9 by 6 kitchen with nine cabinets. Okay. Of course, if your kitchen is the double, then the number changes. Dramatically. But important to know is, based on your need, we can really provide a tailor-made layout and a tailor-made offer. And we would be able to do this in India as soon as possible, because it means that the market finally is picking up as all of us is open. So, thanks to all of you for the attention. And if you have some question, please feel free. Yeah.
Hello, sir. I have a question on the nesting methods.
Yeah.
In nesting, while drilling it through, we need at least 8 mm of material will be lost, whereas in cutting we'll use around 3 mm of material. So more amount of material is being lost in nesting as compared to a normal cutting method.
You know, you have to consider in any case that you can better optimize the space that you have available on the board. If you're talking about the spoil board?
No, not the spoil board. The main board, when we nest it,
yeah.
If we are cutting square or rectangles.
You cut with the tools instead of cutting with the blade.
Yeah, we cut with the tools.
The tool can be 10, 12 millimeters, and the blade would be a 4 millimeter blade. So you have slightly less waste in the nesting for the tools itself. But of course, the possibility of optimizing the different shape in the boards is also there. So according to the size of the board and according to the size of the panels that you need to achieve, it's possible to make a small study and then to tell you if in itself you can have less waste starting from the nesting or starting from a beam saw.
Okay, thank you.
If you want, we can do it quite easily.
No, that's fine.
Okay. Some other question? Okay, thank you.
Excuse me. There's a question. Yeah, actually this CNC rotor machines like vertical CNC drilling machine and the flatbed. I've heard some people saying who are already using that if you use these machines on the ply, because in India we more do with the kitchens with a ply. So the stability of the machine is lost. Is that true? Or?
For sure, the vertical machine cannot grant you the precision of the horizontal machine. Cioè, in the vertical machine, the panel is held with a gripper. There is a gripper which holds the boards and move the boards in the x-axis, let's say. Yeah. Then the head moves in y. While on the flatbed machine or on the machine with pulse rail, the panel is held much better than with the vertical machine. So if you use plywood, it would be suggestible or to decrease the speed, because of course also the speed that you use on the vertical machine can affect the precision of the vertical machine. Or to use a normal CNC, where since the board is held much better with the caps, you are sure that it's not moving. Okay. So going back to your question, for sure the machine with pulse and rail, if you work plywood, can be more precise rather than a machine vertical.
Thank you.
Welcome.